So in this video, we are going to talk about inverse functions. Inverse functions are functions that undo the action of the original function. So basically like the opposite of that function. So the first thing that you're going to do is you're going to want to rewrite this equation with a y in instead of your f of x. So I'm just going to do that real quick. And I'm going to write my x and my y in different colors. You'll see why in a second. All right, so why I'm writing them in different colors is because what you need to do to solve and find an inverse function is you actually need to flip the x and the y. So the x now becomes where the y is, and the y goes where the x is. Everything else you'll notice stayed the exact same. All right, we just switched where the x and the y were. Now, because we always write equations y equals, I need to solve this equation for y. So the first thing I'm going to do is I'm going to subtract 5 from both sides. So I have x minus 5 equals y squared. We all know how to undo a square. We take the square root. So I'm going to take the square root of both sides. Can I take the square root of x minus 5? No, I cannot. Can I take the square root of y squared? Yes, it's y. So I have y equals the square root of x minus 5. That is our inverse function, so I need to denote it as such by using function notation. So the inverse function equals the square root of x minus 5. And that is my inverse function. Now, I want to also talk to you about other functions besides quadratics. So this example, we did a quadratic function. In this example, it's a rational function. So let's look at this rational function here. I'm going to again suggest that you rewrite the f of x as a y first, keeping everything else the same. And then remember, our first step to find an inverse function is to switch the x and the y. So x equals 1 over y plus 4. Now we have to solve for y. So the first thing I'm going to do is subtract 4 from both sides. So I have x minus 4 equals 1 over y. Now here's where things get a little tricky. Because right now, you're like, oh, y equals x plus 4. But not really, because it's the denominator. We need to get it out of the denominator. So in order to do that, we multiply both sides by y. So that gets us out of the denominator. So we have y times the quantity x minus 4 equals 1. You might be super tempted to distribute that y, but don't. It'll make your life way harder. Remember, we're solving for y. So what do we need to do if we're solving for y? Well, we're multiplying y times this quantity. So to solve, we need to undo that by dividing. So we're going to divide by that whole quantity x minus 4. And then, as always, we do that to both sides. So those then go completely away, and we're left with y equals 1 over x minus 4. Writing that in function notation, of course, we have the inverse of f equals 1 over x minus 4. I want you to take note of something real quick just to recognize this pattern. The pattern is, look at where the 4 is from the inverse function to the function, and look at the sign of that 4 from the inverse function to the function. This will hold true for pretty much any rational function, is if it's the k, it will now be the h opposite sign. If it's the h, it'll now be the k opposite sign. So if we started out with this, see how right now it's the h, and then if I worked my way backwards, I would get this to be my inverse, so it would end up as the k. So that's just a really quick trick for you. You might not be able to use it in every instance, meaning you can check your work that way, but your teacher will probably want to see all the work associated with how you found the inverse. So I hope that with these two examples of rational functions and quadratic functions, finding the inverse of both, you've kind of been cleared up a little bit on how to find the inverse.